Hi everyone, welcome to another video, and today we're going to discuss DFS, that is depth first search. DFS is one of the important algorithm that is almost asked in every interviews, and DFS is used to solve questions regarding trees and graphs. And there is a basic structure of all the DFS, and based on the questions the flavor changes here and there a little bit, the logic. Otherwise the basic structure remains the same uh, for all the DFS. So in Blackboard we have a binary tree and a graph. So we're going to see how DFS works for a B tree, and then we see it how it works for a graph. So if we consider the B tree, we're going to start from the root and we're going to keep going to the depth. Depth in the sense until we reach to the leaf node, we're going to keep going to the depth. So from 1, we're going to start and we're going to keep going to the left. So we're going to go to 2. From 2, we're going to go to the left again and we're going to reach at 4. Now we don't have any children, that is null and null, so we're going to backtrack. So backtracking is kind of an integral part of all the DFS problems. Now we're going to go to 2, and 2 has a right children, so we're going to go to the right here. And 5, the node 5 don't has any children, so we're going to backtrack and go to 2, and from 2 we're going to go to 1. Now from 1 we're going to go to right to 3, and 3 has left children, so we're going to start going to the left. We're going to go to 6. From 6 we're going to go to 8. 8 don't has any children, null, so we're going to backtrack and we're going to go to 3. And in 3 at 3 we have a right children, so we're going to go to right. We're going to reach at 7. 7 don't has any children, so we're going to backtrack and go to the root. And that's how DFS works in case of a tree. Okay, now in the right side of the screen we have a graph, and if you see, the graph has multiple cycles in it. For example, 1, 2, 4, 5 and 3, 2, 4, 3, right? So here we have to keep track of visited nodes. Otherwise, there is a chance that our code will go into infinite loop in recursion. So we're going to keep track of a visited nodes, and we're going to start from 0, right, from here, and we'll add 0 to our visited node. From there, we're going to go to 1 or 5 in any direction. So let's start with 1. Then we're going to add 1 to our list, and then we're going to go to 2. We're going to add 2. From 2 we can go to 3 or 4, but we're going to go to 3. We're going to add 3. Now we can't go anywhere from 3, so we're going to backtrack. We're going to go to 2, and now we see from 2 we can go to 4. Now from 4 we can go to 3 or 5. So now let's go to 3. If you go to 3, 3 is already present in visited, so we have to backtrack. And now we only have one way to go 5, right? We add 4 here. Now 5 is not there, so we're going to go to 5. We'll add 5. From 5 we can go to 1, but 1 is already present here, so we have to backtrack. And if we backtrack, it will come to 1 and to 0, and from 0 only one way left, that is 5, but we already visited 5, so it will not gonna go anywhere, and we covered all the components. So in case of a graph, it works the same way as we did in a tree, binary tree. In binary tree we have to go to left and right, but in case of graph we have to maintain an adjacency list. Adjacency list in the sense every component, for example, 0 component in the graph will have an adjacency list that will contain 1 and 5. So where are we going to go? So we can consider as the children of a node, right? So from 1, where are we going to go? It will have only 2. And so on. We're going to maintain an adjacency list, and we're going to run our DFS on every neighbor or every adjacent components. And when doing so, we have to again maintain a visited list so that we can deal with the cycle. Otherwise, the logic remains the same as B tree. B tree has only 2 children. In here, the adjacency, we can call it adjacency list, and it can have multiple components, and they may repeat also. So binary tree are a special case of graph. We can say that a subset of graph is binary tree. So now using DFS, we can see that we can solve or we can traverse through all the children of a binary tree, or we can traverse through every component of a graph. So now in subsequent videos, we're going to solve multiple questions using DFS. First, we're going to start with easy ones, and we're going to go to medium, and then we're going to go to harder ones. So stay tuned. Thank you for watching.